Okay, so now I'm going to solve these perfect squares and put them into a factored form. So something to remember when solving the perfect square is this formula. A squared plus 2ab plus b squared is equal to a plus b squared. Now what this formula says, that if you have this equation, it should look like this. So right here we have that equation as 4m squared plus 4m plus 1. Now we know this is a perfect square because it is a trinomial, and the a value and the c value can be square rooted. So if you have a trinomial with the a value and the c value which cannot be square rooted, then it is not a perfect square. So to put this into this expression, we will find the do the square root of the a and the c. So what you get here is 2m and then 2m. So we have two brackets which will give us 4m if you multiply 2m by 2m. So 2m times 2m will give you 4m squared. So you know that that's right. Now we will go to the c value. 1. We have to square root this 1, and if you square root it, we will get 1. So we put that on each side. So 1 times 1 is equal to 1. Now we just take this middle sign and bring it down to each equation. So we just put this plus here and this plus here because the middle term is a plus. So now we have 2m plus 1 times 2m plus 1. And this is a plus b squared because we can also write this as 2m plus 1 squared, which is the same as a plus b squared. So going on to our next problem, we can square root this and square root this. So we know it is a perfect square. So we have our two brackets. So the first number, we put x and x. We can square root this, we'll get x. We put 1x here and 1x here. Now we will square root this 25 and we will get 5 and 5. So 5 times 5 is 25. Now we bring the middle sign into both of them, which is a plus and plus. So now if we FOIL this out, we will get this answer. X squared plus 10x plus 25. If we FOIL this, we will get this, so we know our answer is right. So same thing with here. Square root this, square root this. Here we get 2y and 2y. Square root this, we get 3 and 3. Now since here the middle sign is a negative, we will put a negative here. Minus 3, minus 3. And now if we FOIL this, we will get that. Now going on to our last problem. Square root this, square root this. Here we get an a. And here we get an a too. So when we multiply, we'll get a squared. Square root 64, we get 8. Put 8 here, 8 here. Bring the middle sign down. Negative and negative. And if we FOIL this, we will get this. So this is how to solve a perfect square. Now, we will switch to the difference of squares, which is almost the same but just a little bit different. So the equation for this, for the difference of squares, is a squared minus b squared is equal to a plus b times a minus b. So this is the equation. Sorry, it's a little hard to read, but a plus b times a minus b. This is what we are gonna end up with, because if you FOIL this out, we will get a squared minus b squared always. So here we have a difference of squares, and we know this is a difference of squares because it is a binomial with a negative sign in the middle. So basically what we have to do now is we have to do the same thing but a little bit different. Let me show you. We will still have two brackets, but we have to know, So we see one bracket has a positive and one bracket has a negative. So you know that will be like that. We will follow the same rule by square rooting both of them. So square root of x squared is x. Put x here. Square root of 36 is 4. No, not 4, sorry. Okay, the square root of 36 is 6. So 6, sorry. 6, not 4. So x plus 6, x minus 6. As you can see, this is the same as a plus b times a minus b. So we know that our form is right, and if we FOIL this out, we will get this. And one way to know if in a expression is a difference of squares is that if we can't square root the two terms like we did with the last ones, then it is not a difference of squares. So we will square root this and square root this. We will have our two brackets here, plus and minus. It doesn't matter where you put the plus and minus. So we square root this, we get 2k and 2k. When we multiply 2k times 2k, we will get 4k squared. Now we square root 25, and we will get 5 and 5. This is also the same as a minus b times a plus b, or a plus b times a minus b, so we know it's right. And when we FOIL this out, we will get this answer again. So going on to our next one, square root this. You know, we have two brackets, 1 plus, 1 minus, 9p, 9p, and square root this, we'll get 7q, 7q. And that is our answer for this one. And going on to the last one. So here, we cannot square root a 2, but we can take out a common factor, which is 2. So we put the 2 on the outside. So we will take the 2 on the outside, and what we are left with is a to the power of 4 minus 81. And now we can do, so now we can square root this, and we can square root that. So now we just carry on as before. We just take that outside, so 1 plus, 1 minus. So square root of a to the power of 4, a2, square root of 81 is 9, and 9. So what we did differently here is, since we couldn't square root this, we tried to take it out, and it worked. So we took it out, and then we divided it by both, and we got a to the power of 4 minus 81. And if we take this 2 out, it looks like the same, a difference of squares. So you just ignore the 2, don't let it confuse you. Just leave it out and do as we did in the start, and just put the 2 on the side. And this is how you solve a difference of squares.